Okay, as usual, we're going to start talking about Mars. Something a little different today. Um, Generally, up to now, we've been talking pretty much about the main mission that the rover has, which is to collect samples that might tell us whether there's ever been life on Mars or not. But there are other parts of the scientific mission as well. And one of them is to study the weather on Mars. And we got this interesting picture this week. Oops, sorry. Back up one. What this is just the same thing being shown over and over again, but it's a picture of a dust cloud picked up by the cameras on the front of the rover. And you can see that that's a pretty extensive cloud. And you can understand now why the helicopter's having a problem with dust on the solar panels. If you have dust clouds like this passing by, you can see they would deposit lots and lots of dust. So Perseverance does its study of the Martian weather, both by taking pictures and by using a bunch of environmental instruments that measure things like the wind speed and direction, barometric pressure, of course, temperature, and so on. And so it's collected quite a bit of weather data. And the interesting thing is that it seems to have found something that's unique to its location. As you know, we've been sending rovers to Mars for a long time, 15 years or so. And pretty much all of them have at least gotten pictures of what's going on in locality, and they've usually had some form of weather instruments. And what Perseverance has turned up is that there are a lot more of these dust clouds in its location in Jezero crater than at any of the places any of the other rovers have been. And this gives the planetary scientists an idea that they may actually be seeing not just a local weather pattern here, but a global weather pattern. The reason they think that, this location, the crater, is just south of the equator on Mars. And if you look at the Earth's weather, there's a pattern in where there are winds that blow close to the equator on the Earth. They're called trade winds. And this has been known for a while. And on the Earth, it has to do with several things. One of the things is the fact that at the equator, there's not much difference between how fast the Earth moves from one point to the other, but there's a slight difference, and it's a little faster at the equator. Another thing is, and this is something that's very characteristic of the Earth, if you look at a globe, you can't help but notice that most of the land area on the Earth is in the northern hemisphere, and most of the water is in the southern hemisphere. The South Atlantic and South Pacific Oceans are huge compared to the North Atlantic and North Pacific. And because there's so much water there, because of course the equator gets more sunlight than any other part of the Earth, you get some particular weather conditions going because of that. And the result of that is this kind of persistent trade wind pattern near the equator. Now, of course, Mars does not have any oceans of any type, and so that can't be a factor in what they're seeing on Mars. But maybe there's something else that they can figure out that will explain exactly what's going on and why they're seeing more dust there than at any other place on Mars. Okay. I promised you last week that we were going to look at a design that NASA has come up with for the next version of a Mars helicopter. And this picture shows you one possibility they're looking at. It's a helicopter that has not one set of rotors, but 6. And the reason they designed it with so many rotors is they want this helicopter to be able to carry a much heavier payload than Ingenuity does. Ingenuity, basically, it's got its cameras, it's got its computer equipment, it's got its radio communications equipment, and that's it. That's all that's on there. So what they're realizing now that we know for sure that helicopters are capable of flying on Mars, that if they gave the helicopter more lift so that it could carry a heavier load, then it could actually do some other scientific experiments. It could do some of the things that the rover can do. It could, for example, have a laser spectroscopy instrument so that it could fly up and hover over a rock and zap it with a laser and collect the reflected light and analyze that and learn something about the composition of the rock. Now, the main instrument that rovers have that seems unlikely for a helicopter is the robot arm. The one that's currently used on Perseverance is much, much too heavy to be carried by a helicopter. But it's possible that they might be able to design some kind of little miniature robot arm that could do some of the work done by the rover's robot arm, which would mean you'd have an even more valuable scientific instrument. And the fact that the thing can fly means that it can, for example, go up right next to a cliff face and go halfway up and do analysis there. If you found a cave that had a big enough entrance, the helicopter could actually fly into the cave and it could do analysis on what it found in the cave. So there are just lots of possibilities that make this a very worthwhile thing. Unfortunately, this is not something that's going to happen anytime soon. And it's not because of the time it would take to design and build such a helicopter, though that's certainly a consideration. But the problem comes from the thing that we mentioned before, that if you're going to send a spacecraft from the Earth to Mars, it has to happen at a certain period of time. It has to happen when the orbits of Earth and Mars are aligned in such a way, the Earth being further in towards the sun moves faster. And so as the Earth begins to catch up to the position of Mars, is the time that you want to launch your spacecraft. And then it will pick up the velocity from the Earth to push it part way towards Mars. And it will be able to get there with the minimum expenditure of fuel. The problem is that this kind of orbital configuration only happens every couple of years. So the last launch was in 2022. We're coming up on 2024, but there's not a planned launch in 2024. And the reason is the next planned launch is the sample return mission that's supposed to go and pick up all these sample tubes that Perseverance is going to leave on the Martian surface. And they just did not figure that they could possibly do all the stuff that's involved in that mission in the 2 years between 2022 and 2024. So it was always planned to be 2026. So that means that there's not a free launch window available for a Mars mission until 2028. So that's the first time that it's reasonable that such a helicopter could be sent to Mars. On the other hand, that gives plenty of time to do the design work, build a helicopter, and test it. So I think it's almost certain that in 2028, you'll see such a helicopter go to Mars and participate in the exploration there. We also have some news about Ingenuity. We had left it in where they had figured out that, oh, we got this problem because the solar panels have been covered with dust and the batteries aren't charging enough, and because of that, it's not able to keep all its instruments going overnight. And they finally figured out they had lost communications because the clock had reset, and that caused it to try to communicate at a time that the rover wasn't listening. And they found a workaround for that, so that they can now successfully communicate between the rover and the helicopter. But in order to build a battery charge up, they figured that they had to cut down on the use of heaters, which they've been using to deal with the fact that we're in winter on Mars now, and overnight it gets very, very cold, on the order of minus 100 degrees. And so they were using the heater to keep all the control systems warm overnight. And the problem with that is that it was taking that they don't have as much battery power as they need because the solar panels aren't producing it. And it's taking too much of the battery power to run the heaters, and that just doesn't leave enough battery power to do anything. So they made the decision, okay, we're not going to run the heaters so much. We're going to take a risk with the cold weather, not run the heaters nearly so much, so we can charge at the batteries. Well, it turns out that they've been doing this for since pretty much, I think, the beginning of May. And it turns out that the cold weather is indeed a problem. And they very recently found out that it's caused them to lose one of the instruments in the helicopter control system. It doesn't work anymore. It's something called an inclinometer. I think that's how you pronounce it. And what the inclinometer does, the helicopter, flies and it lands, and it just lands where it lands. And so the way it's oriented with respect to the surface after landing depends a lot on what kind of terrain it lands on. For example, one of the landing wheels might end up on a rock, or one of them might end up in loose sand. And for this reason, you don't know the exact orientation of the helicopter with respect to the ground. And that's important to know because if it does happen to be tilted in some way, then you need to take account for that when it's going to take off. Otherwise, as it goes up, if it's tilted in some way, you might accidentally just fly it right into the ground. And we certainly don't want that to happen. So the purpose of the inclinometer was, it's basically a gravity detector, and it would detect the gravity of Mars, and it had several sensors. And so by figuring out what the gravity is at different points on the helicopter, it could deduce whether the helicopter was flat with respect to the surface or tilted in some way. And that way, then they could adjust the takeoff so as to account for that. So unfortunately, the cold apparently has killed that instrument. It doesn't work anymore. And you might think that, okay, that's it. The thing can't fly anymore. But it turns out they actually have a backup plan for this, because the inclinometer is not the only gravity measuring instrument on the helicopter. It also has similar instruments that are used when it's flying, because they also want to measure the gravity as they're flying, because again, they want to know what their orientation is with respect to the surface. So in that way, when they come into land, hopefully land as smoothly as they possibly can. So it also has those gravity detectors in the flight control mechanism. Now, they're not as sensitive as the gravity measurers were in the inclinometer, but they have decided that they are sensitive enough, they think, that they could do this job of deducing what the orientation of the helicopter is with respect to the surface before it takes off, and hence would allow it to fly. But they aren't designed to do that job. And in fact, the way the helicopter is set up right now, they don't even come on until after the helicopter takes off, because that's what they were for, was to measure what the relative gravitational attraction was when the helicopter was flying. So what they are having to do is they're having to update the control software on the helicopter to turn those gravity monitors on before the helicopter takes off, and have them take the measurement to determine what the orientation of the helicopter is, and thus allow it to safely fly. So they have sent a software update to Mars. They need to install it, and then obviously they need to test it to make sure it's working the way they think it should work. So the helicopter control team said that after they've installed and tested this software update, that they do plan to have a short test flight. So if everything works out, then maybe in another week or so, we'll get another helicopter flight. And that's really surprising, because basically it looked like they had made the decision, we're just not even going to try to fly this thing right now. When we're going to wait until the winter on Mars is over, and we don't need so much battery power for heating, and then maybe we'll try and fly it again. But apparently that's not so. Apparently there'll be at least one flight sometime soon, assuming that this fix works properly. Okay, anybody have a question about that before we move on? Okay, so we've got a couple of interesting medical stories today. This first one says that a doctor has genetically modified T cells to attack an otherwise untreatable tumor. And this is the case of a doctor at a cancer research institute in Oregon, who has come up with a new technique that he used to treat a patient who had pancreatic cancer, which had spread to her lungs. Now, I'm sure most of you are aware that pancreatic cancer is about the worst thing can happen to you. I've unfortunately known a few people personally who got it, and there's only one of those people I know that is surviving now. It generally turns out to be fatal, and often quickly fatal. So it's definitely a very, very serious cancer. And the fact that someone's come up with a treatment that seems to have worked is really, really, really good news. So what happened is this patient had her pancreatic cancer diagnosed. She underwent surgery and radiation and chemotherapy. And for a short while, it seemed like everything was going okay. She went into remission and her cancer stopped growing. But in just a few months, it began to grow again, and not only grow, but also spread to her lungs. And she made a decision. After talking with her doctors, they told her, well, we could do chemotherapy again, but that's not going to do anything except prolong your life for a little bit. Because the cancer is growing, we might be able to slow down the growth, but we can't really do anything to stop it. And so she has decided that she did not want to go through, and we all, I think, are aware that chemotherapy is not a pleasant process. In some cases, actually turns out to be fatal. And it's never, it's always a real challenge for a patient to endure it. And so she said, I'm just not doing that again. And so she started researching alternative therapies. And she found that at this Providence Cancer Institute, a doctor there was doing research on immunotherapy. And what that involves is modifying the body's immune system so that it will attack tumor cells. And it had been used with some success in treating leukemia and some other forms of blood cancer. But nobody had ever successfully treated a solid tumor with this technique. But she wrote to the doctor and asked him if he would take her on as a patient and do a trial with immunotherapy. And he reviewed her case and then applied to the FDA for a single patient trial of immunotherapy and got the trial approved. So what the trial depends on, we know that cancer is always the result of some kind of mutation in our cells. Something happens, and instead of cells behaving normally, they began to grow abnormally and develop tumors and eventually destroy organs in our body. So the idea is to use the fact that there is a mutation here, and that therefore there are proteins produced by the cancer cells that are not produced by normal cells in our body. And so what they did is they harvested T cells from the blood of the patient. Now, we talked a little bit about the immune system before. There are a couple of types of cells in it, but the T cells are the ones that actually attack foreign bodies that they come into contact with. And so the hope is to be able to use them to destroy the cancer. But you have to be careful in dealing with T cells, because they basically just, their role is to destroy things. And sometimes they can mistakenly attack healthy, normal cells in a person and destroy them. And we have to be careful that does not happen. So what they did is they, as we said, harvested some T cells from the patient, and they modified them genetically so that they would be able to detect this mutant protein that's in the tumor cells. And then they did this process of growing a large number of these T cells and then they reinfuse them back into the patient's bloodstream. And the idea being that they would then, because they're able to detect the protein in the tumor, that they would find the tumor and attack it. And so 30 days after they had administered the T cells to the patient, they did a scan of the patient's lung, and the tumors had been reduced in size by 62%. And after 6 months, they were reduced 72%. And so this is, a really great, and while it's not yet couldn't be called a cure, but at least it has successfully put the cancer into remission, and there's hope that it might eventually destroy the cancer, the tumor altogether. And so this institute is going to do a new trial that'll involve several patients and also other different types of cancer, because they would like to see if they can use the same technique against other types of cancer. And we've got some pictures here from the paper they wrote. And this shows, for example, here's one of the tumor cells in the patient's lungs, and 3 months later it's gone, and still gone 6 months later. And here's another one, and 3 months later it's much smaller, and 6 months later smaller still, and likewise down here. So it appears that this is working. Now, interestingly enough, I read this story last week and decided I wanted to include it in this week's class. And then early this week, I read a totally different story about another immunotherapy trial. And we're going to talk about that one next week, because it appears, first of all, it was not a single patient trial. It was a trial on a group of 14 patients who all suffered from rectal cancer. And it had an amazing outcome in that the cancer went into remission in every single one of them. And that's something that almost never happens with any kind of cancer treatment. Almost always you'll find that, it seems to work with some patients and not with others. And so that's a totally amazing one. And we're going to talk about that next week. Okay, any questions about this before we move on?
Bill, I know you said that that'll be discussed next week, but was this a very similar phenomenon? Was this the same immunotherapy approach that was used with the rectal cancer?
I haven't read enough about this one yet to know the answer to that. So
okay,
I just saw the headlines, and then I saw it like 5 different times, which convinced me, okay, this is true, but I haven't had the time to look into exactly what they did. So we'll talk about that next week.
Okay, thank you.
Other questions? Okay, let's move along. We have another medical story. This one involves 3D printing, which, get a couple things that get my interest. I'm about to talk about it. So this is the first successful transplant of a 3D printed ear. This was work that was done by Biotechnology Company, and it involved treating a patient who suffers from a condition called microtia, I guess it is. And microtia is a condition in which the one or both of your external earlobes don't develop properly. And so this is a patient in which the right earlobe had not developed. And so this company decided that they would see if they could 3D print an earlobe for the patient. And then have it transplanted to the patient. And so what they did is they 3D printed a substrate, basically something in the proper shape, from a hydrogel made from collagen, and then they printed a layer of the patient's own cartilage cells on top of it, and then it was attached to the patient. And of course, the idea is that since it's got the collagen is something basically made of it's a carbon compound, and so the body won't try to reject that. And then the fact that you use the patient's own cells means that it won't attack them either. And so there's reason to believe that the transplant will work fine. Now, it's important to notice here that this is not just cosmetic surgery. It's not done just to give the person a normal looking ear. If you don't have an external earlobe to funnel sound into the inner ear, then it's a lot harder for you to hear. It'd be like, putting an earmuff on and then trying to hear. So it is surgery that has more than one purpose. Now, there's been a previous case of this kind of ear transplant done in China as well. The company that did this say that they are looking into the possibility of doing 3D printing of other organs. They do point out that the chances for success are much greater with an earlobe because the earlobe doesn't have blood vessels. And so that makes it much simpler to attach it. You don't have to connect up blood vessels. So here's a picture showing you this is what kind of earlobe the person had before the transplant, and here's the ear after the transplant. And while it doesn't look perfect, it does look better. It also this person had this is the right earlobe that was transplanted. She had a normal left earlobe, and they basically made this thing match the shape of her left earlobe so that her ears look pretty much the same. Okay. Anyone have a question about this? Okay, well, let's move along. Next story says biologists have discovered the world's largest plant. And you might wonder where it is. Obviously, from the picture, it's underwater. So this is an underwater seagrass. And where it is, it's in the shallows right off the coast of Western Australia. And so it's just a huge patch of seagrass there. It's about 112 miles long. And everybody figured, well, that's just a bunch of seagrass plants growing in the same place. And because it was so big, some biologists thought it would be interesting if they harvested plants from various parts of the patch and analyzed their DNA. And their idea was that, well, you have that many plants, that there's surely been some mutations, and we get some idea of how the DNA varies from one part of the patch to the other. So they went out and harvested from all over this plant, took it back to the lab, and checked out the DNA. And what they found is there's no variation. That it's exactly the same DNA no matter where they got it from. And so what that tells us is that this is not a bunch of plants, it's just a single plant. And so what's going on is that down under the sea bottom, all the root systems of the plants are just a single enormous root system. And so that means that this patch of seagrass reproduces like a vine does. From every stalk, their runners get sent out and eventually create some roots and pop up a new stalk. And this stalk is an exact clone of every other stalk. Now, this is not the first time that something like that has been found. There's, for example, what was thought to be the world's largest plant is a grove of aspen trees in the mountains of Idaho. It was discovered some time ago that it's not a grove of separate trees, that once again, it's a matter of there's a common root system down underground, and that each tree trunk grows from that same root system. And so each of those aspens is exactly genetically identical to each of the other ones. Here's a picture that sort of gives you some idea of what that patch of seagrass looks like. In addition to trees and seagrasses, another place where this happens is mushrooms. In Oregon, there's a huge, and I forget how big it is. I meant to look that up and forgot, but there's a huge underground, basically one monster mushroom that's just growing and growing and growing everywhere. And it was almost as big as the aspen grove before. But now this patch of seagrass turns out to be bigger than either one. So it now gets the title of world's largest plant. Any questions about this? Okay. Now we got another astronomy story. This is kind of exciting information. NASA has announced that they're going to release the first images taken by the James Webb Space Telescope on July 12th. Okay, now you might think that means it's taking images, but it is not yet, although it probably will be very soon. It's still in the process of testing and configuring all the instruments, but it's so far along with that they're sure enough now that they know that they'll be able to produce some pictures and have them ready to release by July 12th. So this is going to be another one of these NASA TV things. And as we get closer to the date, we'll talk about, but it'll be something that you can like go to the NASA website and watch when they first show those images. So it'll be quite exciting. Now, there's a lot of speculation about what those first images will be. What's the first thing that they're going to choose to show. And most astronomers think that what they want to do is right away try to show as much as they can of the full capability of this telescope. So, for example, you would expect that they'll find some images of galaxies from the very, very early universe, ones that are so far away that the Hubble could not have imaged them. So that's one thing you can almost certainly expect to see. And so these might be galaxies that maybe came into existence like in the first 100 million years after the Big Bang. Another thing you probably are going to see will be images of some objects from within our solar system, but where the James Webb will be able to tell us more about these objects than we know now. One of the things that they'll probably look for will be to try to spot some unknown near-Earth asteroids, because everybody's always interested in those, because if they're near Earth, then that, you know, they become potential candidates at some point in the future to actually get too near. And so it would be good if they could show up a couple of those guys to show that it's got the ability to find them. Another thing, although this would take some good luck, but we've mentioned before that there are some astronomers who think that there's a large planet located in the outer solar system that's way out past the orbit of Pluto. And if it is there, then certainly sooner or later, the James Webb is going to find it, because it will emit infrared light, and James Webb has got the capability to pick up infrared light from a planet-sized object that's way out in the solar system. So it would be extremely good luck if they happen to find the thing right away, because nobody knows exactly where it is. They just think it's way out there, but it could. It might be. It would show this thing up. But on the other hand, it may not be there at all, and then it'll take a lot of looking out there and not seeing anything to convince people that there really isn't anything out there. So those are some things that we might possibly see in those first images. Now, once those images are released, then the James Webb will start following a regular schedule of observation. And what it looks at then is determined by a committee, an international committee of astronomers. They're tasked with basically assigning time on the JWST for astronomers. And so anybody who wants to do an observation with it has to submit a proposal to this committee saying what they want to observe and why they need the JWST to do their observation. And then the committee examines those proposals and prioritizes them and sets up a schedule of observations. And the other consideration about scheduling those things, once you get a rough idea of, well, this is really more important, we need to look at it sooner, you want to try to schedule those observations in such a way that you use the telescope efficiently. And what that means is this. We know the telescope has got little rockets that are used to change its orientation so it can change where it looks. And so what you want to do is try to come up with a sequence of observations so that once you start going in a certain direction, you keep doing that until you've gotten everything that you've got to work on right now in that direction, and then you start in a different direction. And in that way, you try to conserve the rocket fuel that's used to maneuver the telescope as much as possible. Okay, so any questions about that? Okay, I've got one more story, and this is about nanotechnology. And when we looked at nanotechnology, we saw that in a lot of nanotechnology applications, we make use of various forms of carbon. We talked about graphene, which is carbon in a basically two-dimensional lattice. We talked about nanotubes, which are two-dimensional lattices are rolled up into tubes. And then we talked about these things called fullerenes, which are three-dimensional structures made of various types of carbon atoms. Well, the graphene is the first example of a two-dimensional lattice of carbon that's been used for nanotechnology purposes. And graphene is a two-dimensional lattice made of hexagons. We got this picture right here that shows how basically each of these hexagons has 6 carbon atoms around the edges that are joined together. And then next to it, there's another hexagon joined in like that, and on and on and on. And it's very symmetric. And because of that, there are certain properties of it that are determined by that symmetric makeup. But the people who work on this kind of thing, or who we call, sometimes they're called solid state physicists, but recently the term material scientist gets used more often. And they have come up with a theory that says that, okay, while graphene is this nice, very, very symmetric two-dimensional lattice, that you ought to be able to come up with other two-dimensional lattices that don't quite satisfy that kind of symmetry, but still combine a bunch of carbon atoms. And so they gave them the name graphene, which is like graphene except with a Y instead of an E. And their theories told them that they should find several different forms of that. And in fact, so they've now been able to actually construct 5 different types. And you can see, while they all have a certain kind of symmetry, they're a little bit different than the graphene. This one kind of looks very similar, but it's got these bonds between these pairs of hydrogen atoms like this that kind of go slanting across the lattice. And if we go back and look at the graphene, you don't have that kind of bond there, like between this atom and that atom over there. So that's what the difference is. So they managed to make this stuff by making use of some techniques that they borrowed from organic chemists. And basically it consists of starting with graphene, starting out with the nice hexagonal symmetric pattern, and then adding additional carbon atoms. And they get the different shapes here by heating the lattice to a certain, if you heat it to one certain temperature, you'll end up making something like this, and another temperature like that, and so on. So it's basically just a result of taking a technique that's used somewhere else and figuring out it'll work in this situation, and starting to produce this stuff. And they're able to produce it in pretty large quantities. So the next step is to look at the properties that it should have, because their theory tells them that, for example, it should be whereas graphene is known to be a very good conductor of electricity, this graphene form should be an even better conductor of electricity. And so that means their applications, graphene is used in a lot of applications involving electrical conductivity because it conducts very well. Same thing is true of conduction of heat. These materials should be even better conductors of heat than graphene is. So there are lots of nanotechnology applications that might benefit from this new type of material. Okay, anybody have any questions about this one?
Yes, what form is this material in? Is it like sheets or
It's
wires?
just a sheet.
or-
Yeah, it's just a a flat sheet. That's what graphene is. And one of the properties of graphene is that it makes an excellent lubricant, because if you put sheets of graphene one on top of the other, they'll just slide across each other. And so this probably has some of those properties as well.
Thank you.
Other questions?
Have they actually produced any of this?
They have produced it, but they haven't yet been able to verify that it's got all the properties that they hope it has. So they're able to make it, but they don't really, at this point, can't verify what they can do with it yet.
I'm trying to visualize this, but I'm going back 60 years to my organic chemistry courses, and I'm seeing that triple bond between in the graphene 5 between those carbons. And in simpler things, one gets that in acetylene, for example, which, as you know, can be highly reactive.
Right.
And I'm wondering, well, it originally see what develops here. Because I'm not really visualizing it very well, but I was wondering whether it actually produced it. You say yes, they have.
Yeah, they produced it, but and you're right that because the article that I read said that basically the process of producing it is similar to the way that they produce acetylene from other organic compounds. So
Yeah. Okay, thank you.
all right, other questions?
Yes, I have a question. On these different ones, 1 through 5, is it just the size that's different?
Now, if you look carefully, it's actually the thing that Tim was mentioning, the kind of bonds that occur between the atoms. If we go back to look at graphene, here you see that the bonds all are on the outside of this little ring. So there aren't any bonds that go into the interior. But if you look at these, then in each case, they're bonds that come across the interior of the basic shape that defines the lattice. So that's what it's, how many of those bonds that there are and exactly how they connect up that defines the different types. Okay, well, I would like to thank everybody for joining us today, and like to invite you to come back next week, where we are definitely going to cover this other story of the immunotherapy cancer clinical trial. Hopefully we'll have some news from Mars and whatever else, other kind of story I can find. So thanks for coming today, and I'll see everybody next week.
Thank you.
Thank you.
Thank you.
Thank you, Bill.